Welcome to this simplified tutorial of miRViz. A comprehensive PDF tutorial is available to download on the website. Users can load their microRNA datasets, such as sequencing data, and display them onto various networks to quickly identify and show interesting groups of miRs, such as families of microRNAs, groups of miRs sharing similar target, and clusters of microRNAs on DNA. You can access miRViz directly or after typing miRViz in Google. You can choose a species, here human, and a network, here SID27. To have a wider view, you can display the network on one column. You can also mask or display the left band. In all the networks, each circle, called a node, is a given microRNA. In this SID27 network, two nodes are connected if the corresponding miRs share the same SID. One way to zoom in and out is to roll the mouse. Waiting 1 second on a node displays more miR information. You can click on the link to switch to the corresponding miR base page of the miR. On the left band, there is a button to manually control if information should be displayed near miR nodes. Part 3. Overlay miR data on the network. First, let's start with preloaded data. I chose for this demo normalized miR expression in log2 scale from the miRMIND database. 4 color scale is good for differential expression. Here, I choose a 3 color scale. I chose white for absent miRs or miR with very low expression, that is, white color if expression is below 4. White-blue gradient for expression between 4 and 8. And blue-red gradient for expression between 8 and 12. Pure red is for expression above 12. You can see highly expressed family of miRs, here LED75P, suggesting a redundancy of miR repression. You can move, zoom in and out to find other families. Here we also see the miR30 family and above the miR92, 25, etc. family. Part 4. Load your own data. Click Load Data on the menu top left. Then click Load CSV. I chose a public sequencing dataset quantifying miRs in a cell line and in exosomes of the medium. Let's have a look on the dataset organization. CSV format is required. The best is to identify mature miRs with their miR-base identifier called MyMat. The first row should contain the names of the variable. 2 columns are separated by a comma. The second row corresponds to the first miR. Again, first column is the MyMat ID. You can also choose the official mature name. Other columns are numerical measurements. Then differential expression called LFC for log4 change. Back to miRViz, I prefer to use MyMat to identify miRs. I select the numerical column I want to use, here LFC. Let's switch back to the network part. In the Colors submenu, I can select the loaded dataset and the variable of interest. For differential expression, I suggest the 4 color scale. Classical colors are green for lower expression, red for overexpression, and white for similar expression. By experience, choosing -2, -0.5, 0.5, and 2 are good thresholds. Zoom 1:1 provides an overview of the whole network. I then switch to 2-column visualization to compare two datasets. I add a new network. I select the dataset and the variable. And again, I set up the same thresholds. The two conditions are now compared on each network. I synchronize the networks to facilitate the comparison. I display miRName for the selected network and apply it to all networks. I mask the left band for wider visualization. I navigate the network to identify interesting mir families. For example, the miR378 family is overexpressed in A33 exosomes, left network, but not in EPCAM exosomes, right network. But the LED7 3P family is enriched in both sorts of exosomes.